Application of linear programming in solving a variety of problems. We're going to use the Microsoft Excel solver function to show how to solve problems applying these linear programming techniques, which is very simple if you have Microsoft Excel available. This is a problem taken from the Russell and Taylor 10th edition. Problem number 9. This problem says that this company, they are going to make 3 different brands of blends of gasoline, the regular, premium, and super blends of gasoline, and the components they mix to make this gasoline, also their cost and their availability, the number of barrels, and also the restriction given for how do you mix to get all these 3 different blends. Now this is a very typical situation to many problems like this. Let's say you are cooking something, you want to develop a recipe, you're going to, there's so many variety, fertilizing some land, different kinds of fertilizer, paint, that you mix different various components to make certain type of paints, things like that. So this is very, very common, a very common scenario. So understanding this problem will help you to solve a variety of problems. So I compiled the data here. You can go back to the video to see this data. So this is basically given. It says that demand, they produce at least this much amount and they can sell it for this amount, and it costs this. So to solve problems using Microsoft Excel, this solver, there is a function under data tab called the solver. If you don't see that here, you can right click here, customize ribbon, and you can go to add in, and then under this here, Excel add-in, and check that box as solver add-in, and it should show you that function. So Excel, it is start with zeros and then fill this number with the optimum solution. A lot of this will be self-explanatory towards the end of the video, so just stay with me. So basically this is the variables that we're going to solve, and it start with the 0. So total used, there are a few things we need. So now we're going to develop or clean this data in a way so we can set all these constraints for the linear programming solver function. So we need to sum the total amount of component used so that we can set that should be equal or less than whatever you have available here. So this will be set as less than or equal to this in the solver function later on. And then we have the demand, so we can say produced equal to sum of these 4 components to produce this super blend, and same for these 3 other blends. So and that should be more than equal to this, because they said they produce at least 3,000 barrel or 3,000 barrel super and premium, and 4,000 barrels of regular gasoline. So this is the use condition. Now there is a condition for blend mix. You can go back to the video here. There is a condition given for how do you produce super blend by mixing these different components. So we're going to show that now. So basically I'm going to write here the blend or mix. So super, then premium, then regular, and then I'll say component 1, 2, 3, and 4. So this has restriction on that. So the restriction for that is you can, let me see, go back there. I'm going to, let's see which one would be easier to use. There we go. I'll just move that to the in my other screen. So So the first restriction for component 1 in super blend, it says not less than 40% of 1. So total super is produced this much times the 40%, and that will send, we send those constant later. So component 2 not more than 20%. So the total super is produced this much times 0.2, and then for component 3 is equal to total super is this, and then times the 30%. For premium, they have restriction for blend for component 2, that is 50%. So 0.5 of component 2 is not sorry, the yeah, for the component 2, for the total premium produced is this. So 50% of the total premium is that value is equal to there is a restriction for component 3. It should be more than 40% of component 3. So 0.4 of this is the total premium produced. Regular only has only one constraint, which is 10% of component or not less than that. So this is the total produced, 10% of that is this. Now the profit we can calculate by basically the total selling price. We can, this is the produce and this is each barrel is sold for $12, and this is the number of barrel produced. So we can multiply this and this plus this and this plus this and this. So there is a function in Excel called sum product that will do that operation. So sum product of these comma these. Now this is the price minus the cost, which will be the sum product again of this cost per barrel times the amount used for each of these components. So that's the profit. Now I'm ready to go to use the solver function. Before I go there, I like to have a copy of the data. So that's my clean data so that I can use the solver function, clean for the solver function, and then this I will name as solution, because there is so many things going on. So in case something doesn't work right, then I can go back and change that. I will not lose this data, because once I hit solve, everything will change. So I'm going to maximize the profit, which is in this cell. So this is default, max is selected, so that's good. It's going to change this. That's what I want the solver to give me. And then I'm going to add some constraint, and it will use the linear simplex algorithm. So the used must be less than or equal to what we have available. Add, and then it says we produce more than these values. So they're going to produce at least 3,000 barrel premium super and 4,000 barrels of regular gasoline. So add, so we're done with this constant. Now we are going to do this constraint. So if you remember that condition which we have here, so you can go back to the video here. So I'm going to basically move it to the next screen so I can. So the first condition for the super blend is not less than 40% of 1. So the total component in super blend, that's the total for component 1 in super blend, that shouldn't be not less than 40%. So it should be greater than this guy. Add, and then component 2 says not more than 20%. So that's my component 2 in super blend, not more than 20%. So it's going to be less than this value. Add, and then for component 3, that says not less than 30%. So it's going to be more than of that value. So I'm done with super blend. I'm going to add for premium. So premium, it says not more than 50% of component 2. So that's the 50%. So it's going to be less than that. And then component 3 says not less than. So this is the total in total component 3 in premium, not less than. So it's going to be more than that value. And now I have the super regular blended. It says the component 1 should not be less than 10%. So it should be more than this value. I think I have all the constraint now. So something went crazy in my Excel. Okay, here we go. Now if I hit solve button, it should produce the result. So I'm going to make it bigger. So this is the solution to this problem. The mixing condition, number of barrel goes to each of these different grades. Here you can see and cost and profit and everything here.